Friend, already I have finished calculus for physics. This is the last part, calculus for chemistry. The review discussed in calculus for physics exactly same for chemistry also. That's why we are discussing some sample problem for chemistry. SP01. A reactant R with initial concentration box R naught undergoes the reaction. This is the reaction. A reactant to product P in such a way that the rate of decrease in concentration of R stays constant. Rate of decrease in concentration R, box R is the concentration of R, box R naught is the initial concentration of R. It is decreasing, rate is decreasing at the constant rate K greater than 0, K is a positive constant. Now we have to find the concentration of R, concentration that is denoted by box R at time T for this reaction. Already explained, you see concentration of R, what does it mean concentration of R? Concentration of R implies number of moles of R present in 1 liter solution, that is mole per liter, that is also called active mass or concentration of the solution. Now you see what is the rate law given in the reaction? Again you see dr dt, that is the rate of decrease. Rate of decrease by rate of change. Truly speaking, rate of change of R, it is constant given in the problem. dr dt is the what? Rate of change of R with respect to time t. It may be rate of increase of R or rate of decrease of R. So here R, concentration of R decreases. So be careful, dr dt is a negative quantity. Because R decreases means dr negative, dt permanently positive, you know. So dr dt is a negative quantity. Again same previous, just already I have discussed in calculus for physics. But K is a positive constant. So if you don't give minus sign, then right side positive, left side negative. So obviously you must put minus sign so that dr dt, minus dr dt is a positive quantity, equals to K. Then the equality will hold. Now then it is a step 1, differential equation is met. Then separate the variable. So dr is equal to minus K dt. Just transfer dt to the right. Then ready for integration. So integrate. Integration of dr is equal to minus K, constant taken out, integration of dt. Already given, you see, at t is equal to 0, initial concentration box R naught, and we are going to find at t is equal to t what is the concentration of R, that is box R. Now integration of dr is equal to R, upper limit, lower limit, minus integration of dt is t, upper limit, lower limit. Then you put upper limit minus lower limit, R minus box R naught equals to minus K, t minus 0. So already you have box R is equal to minus KT plus R naught. Answer. This is the concentration of a reactant R at the moment of time t. And you see, you can also verify, as t increases, it is a minus KT, so R decreases. When t increases, minus sign, minus KT, so the concentration of R decreases. If you miss minus sign, it becomes plus KT. So you will have obviously wrong result. That is, when T increases, the concentration increases. But question is not like that. As the reaction goes on, concentration of R decreases with time T. Now, SP02. A certain population of bacteria is placed in a nutrient solution at time T is equal to 0. And the population is known to grow at the rate proportional to the population present in the solution. Yes, present in the solution at the moment of time T. And it provides the plentiful food and space for the growth of the bacteria. Now if N naught is the number of bacteria present initial condition, and K is a positive constant of proportionality, then we are going to find the number of bacteria N in the solution at any time T. Solution, you see, the differential equation for the given process is what? dn dt is equal to kn. Here you see dn dt is positive quantity because n is increasing. There is a growth of bacteria. Number of n increases. So dn dt is a positive quantity. Be careful. So it is equal to kn. There is no question of any minus sign. So dn dt is equal to kn. Then separate the variable. Dn by n is equal to k dt. Variable separated. That is step 2. Now ready for integration. So integration yields 1 by n dn is equal to k taken out dt. Now when t is equal to 0, initial number of bacteria is what? N naught given. And we are going to find at t is equal to t, what is the number of, yes, number of bacteria, n. Now 1 by n dn is equal to ln n, upper limit, lower limit, integration of dt t, upper, lower. So ln n minus ln n naught, upper minus lower, k t minus 0. So ln n minus ln n naught means what? Ln n by n naught is equal to kt. So what is n by n naught? Ln means log to the base e, so e to the power kt. So n is equal to n naught e to the power kt. This is the answer. This is the number of bacteria present in the solution at the moment of time t. SP03. For a reaction involving reactant A, plot of 1 by concentration of A, that is box A, versus T is given. It is given here. And you see it is given here. And A naught, box A naught is the what? Initial concentration of A at time T is equal to 0. And the slope of the line, tan theta naught is equal to K given. It is theta naught, the line makes an angle theta naught with the T axis. So what is the slope? You know, tan theta naught is equal to K. And clearly theta naught lies in the first quadrant. So K is a positive constant. Now, what is given? The reaction follows the rate law, minus dA dt is equal to K to the power n. We have to find the value of n. Solution. The equation of a straight line, you see, it is a y is equal to mx plus c, you know, y is equal to mx plus c. So the equation of straight line is equal to y. Y means 1 by box A, equal to m. M means already slope k. M x means t plus c. C means what? 1 by box A naught. So y is equal to mx plus c. Y means 1 by A. Yes, m is equal to what? Tan theta naught is equal to k. X means t plus c. 1 by A box A naught, box A naught. Yes, it is a slope intercept form. Now we have to differentiate the equation, because to find the rate law dA dt, obviously we must apply ddt operation. So we have to differentiate the equation. So differentiation, yes, with respect to t yields ddt of 1 by box A is equal to ddt of kt plus 0, because initial concentration is constant, so it will be 0. Now then chain rule, it cannot be differentiated. So dA dt chain rule is equal to k constant taken out, dt of t, chain rule. Now it will be what? Minus 1 by box A square is, you know, minus box A minus 2. So minus 1 by box A square dA dt is equal to k. So what is dA dt? What is minus dA dt? K box A square. It is a rate law. So clearly compare with the given equation, n equals to 2. SP04. It is a problem on radioactivity. A radioactive material decays at the rate proportional to its amount present. If n naught is the initial amount and n is the amount present at the moment of time t, and k is a positive proportionality constant, we have to find n as a function of time t. So the rate law representing the decay process is what? dN dt is the what? dN dt is the rate of decay. Already given, you see, proportional to the what? n, the number of radioactive atoms present in at the moment of time t. And proportionality constant k is given. So dN dt is equal to kn, but be careful. N is what? Decay means n decreases. So dN negative, dt with the increase of time t, n decreases. So dN negative, dt positive. So dN dt is a negative quantity. But again, right side is a positive quantity, because k is positive, n also positive. So we must put minus sign, so that minus dN dt becomes positive, and then the equality will hold. Then separate the variable, dN by n minus dN by n is equal to k dt. Now ready for integration. So integrate at t is equal to 0 given, n is equal to n naught. At t is equal to t, n we are going to find. So same, ln n naught is equal to minus t naught. So then upper minus lower, it will be ln n naught is equal to minus kt. So ln means log to the base e. So n by n naught is equal to e to the power minus kt. So n is equal to n naught e to the power minus kt. This is the n value of n at the moment of time t. Now SP05. The following reaction A plus B gives product P. The initial concentration of each reactant was equal. It is given initial concentration of A and B equal. Note it very carefully. It is very important for this problem. The reaction proceeds in such a way that the time rate of disappearance of A is proportional to the product of the concentrations of A and B. Initial concentration of A is given and the constant of proportionality given is a positive constant K. K is a positive constant of proportionality given in the problem. Then you have to find the concentration of A as a function of time t. Now one thing we remember that the concentration of A and B initially equal and at any moment of time also remain equal. Why? It is a 1 mole, it is a 1 mole. So when 1 mole consumed, 1 mole of A is consumed, at the same time 1 mole of B is also consumed. So if X mole consumed in time dt, so X mole of B also consumed in the same time dt. So always the concentration of A and B remain equal, always. So now come here. Now what is given here, you see? The rate of disappearance, so ddt of A, but rate of disappearance means what? Concentration of A decreases. So again ddt of A is a negative quantity. But right side what is given? It is proportional to product of the concentration of A and B. So K, proportionality constant, positive constant, concentration of A, concentration of B. So right side is a positive quantity, but dA dt is a negative quantity. Again you put minus sign. So positive is equal to positive, equality will hold. And also you know, already explained, you see, concentration of A and concentration of B always remain equal. That's why concentration of A is equal to concentration of B. So we can write K into box A square, because concentration of A is equal to concentration of B. So this implies minus dA, separate the variable, minus dA by box A square is equal to K dt, step 2, that is variable separated. Now ready for integration? Integrating. You have already given when t is equal to 0, initial concentration box A naught, and at time t, the concentration box A is required. So it will be what? 1 by, actually it box A to the power minus 2. So box A minus 2 plus 1 by minus 2 plus 1. So ultimately 1 by box A. It is a final, it is a initial concentration, final concentration. You know what? T, K into T minus 0. Then 1 by A minus 1 by A naught is equal to KT. So 1 by A is equal to KT plus 1 by A naught. So what is concentration of A? 1 by this one, answer.